can we measure addiction-like responses to food without putting a needle in our brain? Yes, no needles required. Ashley Gearhart and her colleagues developed the Yale Food Addiction Scale, and she published that research in 2009, and this is a 25-item self-report scale. And we call it the YFAS, and the YFAS was adapted from the substance abuse dependence criteria in the DSM. The DSM is the Diagnostic and Statistical Manual of Mental Disorders, and that's published by the American Psychiatric Association. It's published every sort of 5 to 8 years, and we're up to number 5 now, so we've got the DSM-5, and so they have a set of criteria for substance dependence, and the YFAS was adapted from that. And so the YFAS measures addiction-like responses to food, and the higher scores on YFAS are seen in binge eating disorder, obesity, and people with increased impulsivity and emotional reactivity. But food addiction can also be seen in slim, normal weight and overweight individuals, and I think that's very much about how insulin sensitive they are, which Marty Kendall referred to in his talk. So not just because you're addicted to food and can't stop eating sugar doesn't mean that you're going to be obese. So using the YFAS with fMRI, what's fMRI? fMRI is functional magnetic resonance imaging, and the YFAS has been validated by fMRI, and in behavioural science it doesn't get any better than that. What does that all mean? Behavioural science is accused of being a soft science. We rely on what people tell us, self-report, or we rely on our observations to make diagnoses. There's no blood tests, there's no x-rays, there's no tissue biopsies. We're relying on information that's open to a huge amount of error. And so what Ashley Gearhart and her colleagues did was that they developed a study which showed that the YFAS is a valid measure for addiction. And so what they did was that they got a group of participants and they administered the YFAS, and they identified who scored highly on this measure, and then they put them in the scanner, and an fMRI measures blood flow in the brain. That's what it does. And so what they were looking for was where was the blood flow going. And so they showed the participants two things, and what they were measuring was anticipation and reward. And they had a chocolate milkshake, picture of a chocolate milkshake, and then they had a drink. And the drink was not water, because water's got a taste, but they actually developed a solution that was saliva-like. It was sort of like, it sounds disgusting, but that's what it was. Anyway, they put them in the MRI scanner, and when they showed everyone the picture of the chocolate milkshake, they scanned their brain to see what would happen, and then they showed them like what looked like a glass of water, scanned their brain, and then they actually gave them the chocolate milkshake, scanned their brain, and they gave them this saliva solution. and what happened? What happened was that the highly palatable food, i.e. the chocolate milkshake, released dopamine. But it only, and what they found was that the parts of the brain that were activated were the parts of the brain that are known to be associated with cravings. And it only happened in the people who scored highly on the YFAS. So it's assumed that craving drives overconsumption, because the other interesting part of the study was that when the high scorers on the YFAS received their reward, which was to drink the chocolate milkshake, there wasn't any activity going on in the craving part of their brain. Again, it's probably assumed that, well, they've already got their reward, so there's no need to be craving any further because they've got it.